the computer. The computer then guides the machines that construct the prototype. One method divides the 3D drawing into cross-sectional layers just a few thousandths of an inch thick. It feeds this information to a laser that's directed at a tray filled with a light-sensitive liquid resin. The laser's light hardens the resin in the shape of the part, layer by layer, eventually constructing the prototype. They rotate the prototype under ultraviolet light for a few hours to cure the resin. Then they polish or paint the prototype according to the requirements of the design. Another prototyping method works much the same way, but uses a fine powdered plastic instead of resin. The computer guides the laser to melt the powder in the shape of the part, again, layer by layer. They extract the hardened prototype from the unmelted powder. Another method doesn't use a laser at all. The computer simply guides machinery to carve the prototype out of a hard material such as wood composite. Once a prototype is ready, they use it to construct a model of the part out of a very durable resin. They'll use that model to make a mold, then they'll use that mold to cast the part out of metal. The resin model dries at room temperature in 24 hours. Its surface must be smooth or else the mold will have defects. They attach channels that will guide the molten metal into the mold. Next, they fill the model with a mix of sand and a binding agent. They smooth out the surface, then number it for tracking purposes. The sand mix takes about 15 minutes to harden into a mold. Now they can finally cast the part. They carefully pour in the molten metal, in this case magnesium, heated to about 700 degrees Celsius. They block the hole with sand to prevent the metal from reacting to the air. The metal takes about 10 to 20 minutes to harden depending on the size of the mold. They crack the mold open on a vibrating conveyor. They use a plaster mold to cast parts that require a better surface finish. Workers position a box around the prototype to contain the plaster. The mold goes into an oven at about 300 degrees Celsius. It takes 48 to 72 hours to cure, but it's not ready for casting just yet. Workers first have to pierce some holes in it to let all the air escape, or else the metal won't flow into all the crevices, and they have to put in filters to keep out impurities. They strap the two halves of the plaster mold together, securing them with metal screws. Workers carefully pour in molten magnesium, using a special gas to prevent the metal from catching fire. Again, they seal the opening with sand. It takes the metal anywhere from 20 minutes to an hour to cool. Then they break open the plaster to remove the metal part. They cut off the channels through which they poured the metal. Then they polish the part using grinders and sanders. Then they paint it using special spray paint that adheres to magnesium. The part is finally finished. It takes several weeks to prototype and tool metal machine parts. When you think about it, even the machines that make these parts